In this one, we're going to have a look at what happens when we have two tangents. Now, I've shortened these tangents. Tangents technically go on forever and ever and ever, so do what we call rays. And what you normally call a line is actually called a segment. But if I move these tangents round so that they cross like so, you see this point here. And the first thing I want you to look at is I'm going to quickly measure the distance between there and there. Ignore this little label it's got on there, but that's 5. And we're going to do the same. I say that, my computer seems to have gone to sleep. We do the same here and here. Okay, just to really prove my point, what I'm going to do is I'm going to make the rounding a little bit more detailed. So rounding, let's just go to 2 decimal places. Let's make these tangents a bit longer. So when I move this, you'll see that the lengths of lines between these two tangents, where it actually starts from, this point where they intersect, and where it hits the circle, they are always the same. So we could put a little line across each of these like we do on isosceles triangles and isosceles trapeziums and other shapes that have the same lengths to say that they are equal. So that's the first thing you need to note. Okay, I'm just going to turn the rounding back onto this. Okay, so we go back to radiuses, or radii I should say. From this tangent, if we draw a line to the centre and therefore a radius, and let's do the same from this one as well. I'll quickly make those red. And we measure these angles in here, so let's just select angle. And we do the same here. Oops, wrong way around. There you go again. Okay, that's fine. Obviously you can appreciate it's 90 on the other side. Ideally I wanted it on the other bit. Let's just move these around. Ugh. Okay, so now we can see the numbers. Okay, so let's move these around and you see what happens. So in fact I can uncross these two tangents now like so. Doesn't matter. But when a tangent and a radius meet, it always creates a 90-degree angle. So we say a tangent and a radius, they meet at 90 degrees all of the time. Now, to remember this one, I like to think of it as an ice cream cone, because if these lengths are the same, like O to L and O to F, they're the same. And that makes a good ice cream cone. The ice cream has a nice little place on top to nestle in. If they were different lengths, the ice cream would fall off. So that's how I used to remember this one, call it the ice cream cone. But essentially you just need to know from the tangent from a point, they're always the same length, from the same point. And where a tangent and a radius meet, it always creates a 90-degree angle. And it's also, while we're here, worth mentioning, because that's 90 and that's 90, so inside this quadrilateral, I've used up 180 inside this kite here. So if I measure these angles, that one, and this one, that makes up the remaining 180 degrees. So the two 90s will always make 180, therefore these two must add up to 180 as well. So that's also a good thing to note with this circle theorem.